Good afternoon, ladies and gentlemen. I hope that your quiz or your Chapter 1 test went well today. We are going to start our flipped classroom. So as I spoke to you in class, you are to watch this video. You are to take notes. This particular video also has a handout. And then I would strongly suggest that as you're taking notes, you go ahead and pause this video, you rewind it and re-listen and work out the problems as you go. Now remember, you are not actually in class, so if you have a question about something, you can't just raise your hand like you normally do. So I would suggest that you make a little note on your handout or in your notes if you do have questions that you come across. That way you can ask them to me once you get back into class tomorrow. Okay, so it's going to take a little bit of getting used to this taking notes stuff at home, but I think it's going to go great. And then, like I said, you are going to take a little notes check quiz after you're done viewing this, and then that'll get sent straight to me, and you'll get a homework grade for that. And then we will actually do your homework assignment during class tomorrow. Okay, so here we go. This is Chapter 2. Chapter 2 is all about linear equations. The first section here is writing linear equations. So these are going to be all word problems. I'm not actually going to have you be solving these. Okay, you are just going to be writing the equation from the information that you are given. I need you to remember, one of the very first days of class, we made this whole list of different words that mean math operations. Okay, so please refer back to this if you need. These are the English words that mean different mathematical operations. All right, so I'm on your handout here, and the first three aren't real life situations. This is just me basically taking math and making it verbal, and I want you to translate it into an algebraic equation. Remember, algebraic means that it has to have variables, okay? An equation means that it needs to have an equal sign. Again, you will not be solving these, you're just going to be writing them. Okay, here we go. The quotient of a number. Well, we know this quotient word right here means to divide. So the quotient of a number and 3. Now, I didn't tell you what to use for your number, so I'm just going to use n. So we'll say n divided by 3 because quotient means divide. Is, now this little is word right here means equals 6 less than another number. So remember, less than is one of those special ones where we have to switch it. So 6 less than another number. Since it's another number, I can't use n again. Let's use m. All right, number 2 here, 15 more than. So again, this is one of those where we have to flip it. So the plus 15 is actually going to come second. The product of a number and 6. So the product of a number and 6 is 11 less than. So less than means we got to flip it. That minus 11 goes at the end. Twice the same number. So since it's the same number, I'm also going to use x again. Okay, last one of these. Half the sum. So I need to do half of the whole sum of 8 and 3 times a number is the same as, that's my equals, the difference, now difference means subtract, 5 times a number. Now, I didn't say if it was the same number or a different number, so we're just going to go with the same number. So I'm going to use x again. 5 times a number and 3. Eventually, we will solve these, just not today. Moving on. My next section, we again are going to translate. This is going to be a real-life situation. Again, do not solve the equation, but I do want you to define the variable if I don't give you one to use. So you have to decide what your variable is going to be. All right, the Daytona 500 is widely considered to be the most important event in the NASCAR circuit. The distance around the track is 2.5 miles, and the race is a total of 500 miles. Determine how many laps it takes to finish the race. The unknown is how many laps, and I'm going to use L for that. So I just defined my variable. So I need to write an equation for this. Well, every lap around is 2.5. So if I take that 2.5 and I multiply it by the L, it better give me a total of 500 miles. So that's one possibility. You also might say, I can take the total of 500 miles and divide it by every lap being 2.5, and that will also give me the number of laps. So either one of those would be correct. A jelly bean manufacturer produces approximately 1,250,000 jelly beans per hour. How many hours does it take to produce 10,000 jelly beans? My unknown is how many hours, and I'm going to use H. And this is very similar to that last NASCAR problem we just had. This company will produce 1,250,000 jelly beans per hour. So if I take that number and I multiply it by the hour, it better give me the 10 million jelly beans that I want. So that is one possible equation. Or I could take that total of 10 million jelly beans that I want and divide it by the 1,250,000 per hour. And when I do that, that'll give me the number of hours I need to be up and running for. The area of the Hartstein's kitchen is 182 square feet. This is 20% of the area of the first floor of their house. Let F represent the area of the first floor. What is the area of the first floor? Okay, so F is the whole first floor, but I know just the kitchen is 20%. Well, I can't just use 20% as it is. Remember, I have to move that decimal 2 spots and make it 0.20. 20% of, this of right here means to multiply, the area of the first floor. So the area of the first floor is F, and that would equal their kitchen, which is 182 square feet. That is one acceptable equation. Another acceptable equation would be to take that 182 and divide it by the 20% that's the first floor, and the 20% that is the kitchen, and that should give you the first floor. All right, we're going to get a little bit more difficult here. Katie is twice as old as her sister Mara. The sum of their ages is 24. How old is each sister? Now it says how old is each sister, and there's 2 of them. So I have 2 unknowns here, but I'm only allowed to use one variable. And I'll say this a lot this year. You want to use the variable for whoever you know the least amount of information about. If I look at this problem, I don't know anything about Mara, so I'm going to make her M. I do know that her sister, Katie, is twice as old as her. So if I want to do twice as old as her, that would be 2 times M, twice as old as Mara. Now it tells me the sum of their ages is 24. Well, sum means to add, so it would look like that. That would be a completely acceptable answer. Or you can put those together because they are like terms, and it would look something like this. Spinfrog Wireless Phone Company bills on a monthly basis. Each bill includes a $29.95 service fee for 1,000 minutes, plus a $2.95 federal communication tax. Additionally, there is a charge of 5 cents for each minute used, over 1,000. Let M represent the number of minutes over 1,000 used during the month. Write an equation to describe the cost P of the wireless phone service per month. So I am trying to find an equation for P. How much is it going to cost me for my phone bill? Well, right off the bat, it cost me $29.95 for the phone, and that's for 1,000 minutes. I also have to pay $2.95 in tax, and then I have to pay 5 cents for each minute over 1,000, and that was M. If you wanted to, you can combine the $29.95 and the $2.95 together. Those are like terms. They both do not have variables, so they both can be put together. And that would give me 32.9 plus 0.05 M. Either one of those would be acceptable. All right, last question in this section here. Deanna and Petra each go for walks around the lake a few times per week. Last week, Deanna walked 7 miles more than Petra. If P represents the number of miles Petra walked, write an equation that represents the total number of miles T the two girls walked. Again, I have two unknowns here. I have Deanna and Petra. They tell me to use P for Petra because Petra I know nothing about. What about Deanna? It says Deanna walked 7 miles more than Petra. 7 miles more. So if Deanna is going to walk 7 miles more than Petra, that'd be Petra plus 7. I want their total to be T. Well, if I want a total, I'm going to add them both together. It would look something like that. Or you can combine your two P's, and that would also be an acceptable answer. All right, last section here. Now, I'm going to give you some information, and I want you to think about what type of problem this would be. So here I'm telling you A is the cost of one adult ticket, A minus 4 is the cost of one children's ticket to the zoo, and then I'm giving you this equation here that you would have written. So if I look at this equation, this is telling me there are 2 adult tickets. This is telling me there are 4 child tickets, and this is telling me the total. Okay, so if I wanted to talk about a problem here, I would say 6 people are going to the zoo, 2 of them adults, and 4 of them are children. It looks like the child ticket is $4 less than the adult ticket because of this right here. And they paid a total of $38 to get into the zoo. Okay, I'm not going to write that out. I just wanted to speak it to you. You're more than welcome to go ahead and write that there as well. Let's go down to the last one here. It says C is the regular cost of one airline ticket, and 0.20 C is the amount of a 20% promotional discount. The equation they give me here has a total of 330. Well, if I look at this C right here is the regular cost. Then I am subtracting this 0.20 C. So I'm taking off the discount, which is what a discount does. It makes your price get lower. So it looks like 3 people are flying on this airline, and they are all getting a 20% discount for a total price of $330. All right, folks, I hope those notes went all right for you. You do have a notes check that needs to be completed. It is just one problem that will be automatically sent to me, and it was just a completion grade for your homework, and I will see you tomorrow morning.